fairly brief topic is thinking about the potential energy of a dipole. Now, in this case, we're again thinking about a uniform field. This is trickier to think through in a non-uniform field. So in a uniform field, we actually said that there was no net force on our dipole. So moving it to the left or right isn't actually going to change its potential energy. But we know that there's a torque. And so there's actually rotational energy here that we have to think about. Because as you do a little bit of a rotation, you're either going in the direction of torque or away from torque. So we're actually going to be talking about angular changes in the energy. So the book does the derivation. I'm not going to go through this derivation. This is kind of a specialty topic, one that we don't really use other than literally this. But what we end up getting is that the potential energy is negative the dot product of this dipole moment with the electric field, or you can think of that as just the magnitude of your moment, the electric field, and then cosine the angle between them. And so your energy actually depends on the angle. So if they're in alignment, right, that's actually when you have negative cosine of 0. And so that's actually here. So in alignment, we are going to say that that has a potential energy of negative PE, not 0. But note that then if this is pointing that way, that's then an angle of 180 degrees. And so you get a minus sign here, which cancels that minus sign. So that is flipped completely all the way around. So this has a sinusoidal shape. What's interesting about this, if you imagine there being a certain angle, you displace it to and let it go, it's actually going to oscillate between these 2 points. So we have a stable equilibrium only when it's pointed exactly away. We have an unstable equilibrium up here, which means that theoretically it could be balanced that way, but if you displace it a little bit, it's going to roll downhill. So hopefully this energy diagram makes a little bit of sense to you. Don't worry too much about the derivation of this. This is an equation that you can use. It should be on the equation sheet.